Welcome to WB Institution, an online educational app. Data acquisition system. The topic seems to be quite lengthier, but I promise you the concept is not going to be that much complicated. It's a matter of block diagram. If you understand a block diagram in this concept, the entire thing is comprised in that. So, this data acquisition system can also be said as DAS or DAQ. In this topic itself, you can find some acquisition. What is that? What exactly acquisition means? It's nothing. Collecting something. Okay, it's called as collecting something. Okay. Now, what I'm going to do is replace this something with a word called data. Okay, means that collecting the data. This is the inner meaning of data acquisition system. Collecting some raw data from a physical world and converting that into a signal. This is the major concept of your data acquisition system. Clear? Just remember a word, collecting data. That is more than enough when considering your topic. Clear? Now, if you go with your definition, it states raw data has been collected. Raw data in the sense a physical component, right? Raw data can be collected, processed, stored and used. So first we are going to collect it. Okay, first we are going to collect it. What you're going to collect? You're going to collect the data, raw physical component data, physical data. I'm going to process it. Clear? I'm going to store it, and according to the necessary it got used. Okay, you can remember this concept in another way. I'll give a simple example. Okay, see, this is not going to be very technical. Just imagine you're going to make a chicken fry. Okay, if you want to make a chicken fry or chicken tandoori or whatever, according to your wish. Okay, if you want to make a chicken fry, first what you have to do, you have to go and buy the chicken from your market, right? So that process can be related to collecting your chicken, means that collecting a data. Over, I got my chicken. So next thing, processing. I have to wash it, I have to clean it, I have to take all the dirt from it. So processing is carried out after collecting the chicken, right? Likewise, after collecting the data, it has to be processed. Fine. To get a fine grilled tandoori or whatever, it has to be it has to be stored with its masala blended with it for an hour. Then only we'll be getting a very spicy chicken grill or tandoori or whatever. So it has to be stored with its masala coated, right? So their storing process is carried out. Likewise, for if in that storing process there is no need you have to go it for 1 hour. You have to do it your storage for 2 hours. Not like that. According to you, you can store it or you can immediately use it, right? Likewise, if you are necessary, you can store the data. Fine. So data has been collected, data has been processed, data has been stored. Finally, according to a usage, the data can be used. According to a usage, the tandoori can be grilled. Clear? Have you understood the concept? Fine. So this is seen to be a basic concept, aligned with your what exactly a data acquisition process is carried out. Now forget about the tandoori. Clear? Yes. Now this process can also be stated as a converting a analog waveform into a digital format. Means that the analog signals are got, that is your physical component signals are got, processed, and then it is got as an output in a digital format. Why digital format? Why? Because mostly the outputs in the display panels, you can see the digital outputs only. It is very easier. In order to get your values, in order to get your results accurate, the digital format is very simple and user friendly. So here also we are going to convert the analog signal into a digital format. Clear? Now, components of acquisition system. See, we'll be having 4 or 5 components. Among that, the most important 3 components will be having. First one is to be a sensor. What is a main purpose of a sensor? Now, sensor used to sense the physical component, that is used to convert it into an electrical signal. It will sense or else it directly sends the electrical signal. Clear? Sensors are used to sense the electrical parameters, that is physical parameters, and it is get converted into electrical signal, or else it directly sends the electrical signal. So first component is said to be your sensor. Clear? Now next component is said to be your signal conditioning circuitry. That seems to be very important. Here, what exactly, see, I'll be saying more detailed when you come to your block diagram explanation. Now, just know what are the important components you have in your data acquisition system. So here, signal conditioning circuitry, it is used to convert this. You have a sensor first, next is said to be your signal conditioning circuitry. So from here, I'll be getting an electrical signal. So this sensor signals into a form that can be converted into a that will make into a form. This will make a form. Converted means that if it has an error, if the amplitude value is low, it will go for amplification. So it will correct the signal in order to give a better digital output. Clear? So conditioning is happening in your signal conditioning circuitry, in your signal conditioning unit. So final thing is that analog to digital converter, as I told earlier, will be getting the output, will be seeing the output in a digital platform. Clear? Clear? Now we'll get into a block diagram. This is seem to be a very important part in your data acquisition system. The entire concept lies in this particular block diagram. Clear? Yes. So first, transducer. You can see a number of transducer over here. Yes, sir. What are the transducer used for? It is used to sense the, physical component, and it is get converted into an electrical signal. The transducer here are used to convert into an electrical signal. Clear? The analog signals are got sensed by the transducer. Clear? Now the output of this will be an electrical signal. The output will be an electrical signal. This is given to a signal conditioners. Already have told that. See, the output which is given by the transducer, it might be having a low amplitude. In that way, the signal conditioning will do a amplification process, and it may contain an error, so it may do a filtering process. Clear? Likewise, it will do a necessary need to a particular signal in order to give a better digital output. Fine. Clear? The conditioning means that taking out all the errors and giving a perfect output in order to get a perfect digital output. Clear? In your output screen. Now, these are given to your multiplexer. What exactly a working of a multiplexer? It will get a number of input, maximum input into a one output. That is the main concept of your multiplexer, right? So here it is obtaining 4 inputs in this block. In this particular block diagram, you can see it is getting 4 inputs. This is going to be a 1, 2, 3 and 4. It is gathering 4 inputs and it will give a 1 output. That is given to this is going to be your output area from your multiplexer. So that particular output is given to your analog to digital converter, as well as you can see a line which is separating from here directly to analog data. I'll make it clear here. See, some systems may need a analog output only. Okay, in that particular condition, before getting into this analog to digital converter, this is directly given to an analog data, whereas from here I'll explain it later. Fine. So we'll see what exactly this analog to digital converter will do. You know that earlier what the analog signals are get converted into a digital signals in this analog to digital converter. Clear? Now coming back to this analog data, see the process, the system has been the data has been collected, the data has been processed. This is the area where collection is happened. Data has been processed over here. Okay, it has been stored. Now storing process is happening. See, if you want to store the data or record the data, here you can see in the analog data record and display. See, recorders will be display will be having, see, displays will be having. So yes, in this you can see the analog data and the digital analog to digital converter, both in the outputs. This is going to be your analog output area and this is going to be your digital output area. So here a digital output is obtained. Now three things are available. One is the recorder, another one is a display, and another one is a storing unit. Okay, so if you consider the display, you'll be having you will be having number of displays. Among that oscilloscope, numerical display, panel meter. What exactly a display, ma? Where you can see the output, means that what exactly the input what you have given, you can see it in your display, right? So that is what your display, the oscilloscope, numerical display, panel display, these are the different kinds of displays you can see. And when you come to your recorder session, you'll be having like optical recorder, ultraviolet recorders, stylus and ink recorder. These are the different varieties of recorders you'll be having. So in this recorder, if you consider the recorder, the data can be stored temporarily or else it can also be stored permanently. If you want to make a permanent storage, you can make it, or else just for time being, I just want to store a particular data for a time being. In that concept also you can store it for a temporary purpose. Clear? Now if you consider this storing element, magnetic tapes are used to store, disk is used to store, and floppy disk are used to store. These are the some of the storing materials which are used to store your data which has been transmitted. Clear? These are available in your output sessions. Fine, hope you understand. First you will be getting into your collecting the data, then processing your data. The processed data are get stored and then it is used according to their usage. Clear? Now we'll be seeing about the objectives of your data acquisition system. If we consider the objectives, the first and very foremost objective is said to be collecting the necessary data at a correct speed. Means that have to collect the necessary data. Means for example, if I ask my data acquisition system to collect particular data, for example 0 to 1, just consider I'm going to have a sequence, no, it is an analog input, right? So these are the different analog inputs I'm having. Okay, these are the different analog input I'm having. Just state this as a, state this as B, and this as C. I just want to collect the B and to process it. So my acquisition system have to collect the correct data. Means that it has to collect only the B option and process it. Clear? The unnecessary data should not be collected and it should not be processed. Fine. Hope you're clear with the first point. Next is that it should use all the data efficiently to inform the operator about the state of a system. Means that the collected data should be used efficiently. Okay, there should not be any the error in a particular thing. The processing should be perfect. The efficiency of a data should be maintained perfect. So second one is the first one is your data collection. Second one is your efficiency of the data which you have collected. Means the data acquisition process have collected. It is got sensed. Right. Next one is said to be, it must monitor the complete system operation to maintain online optimum and safe operation. So why this point they have given means, see, in the operating system you will be having number of processors, right? First you had your transducers, right? Next you had your signal processing unit, next you had your multiplex analog to digital, and so you'll be having number of blocks. The particular data are going inside all the blocks and coming out, so the proper monitoring of your data is very necessary in order to get a efficient output. So that only they have stated here that the complete monitoring of a system is very important. Fine. Now next one is, it must summarize and store the data when it is diagnosing the operation and record purpose. Means that, see, if I consider my output area, what will be in your output area? You'll be having your recorder and you'll be having your storing unit, right? In that area, after all the processor, the data is got recorded or else it got stored in that particular unit. Okay, but the data acquisition system has to record the correct, has to collect the correct data, and it has to summarize it proper storage. See, if I want to collect all the blue colors, the blue colors has to be summarized in one format. If I want to collect all the red colors, the red colors has to be collected and summarized in a separate format. The blue and red should not mingle together. If I ask the output, I need a blue color, they have to give me only the blue color, not the combination of a blue or red. Then my process is said to be wrong, right? And my system is said to be errored. So the summarizing the data has to be in a proper format in order to get a efficient output, in order to get my very correct output. Clear with that point? Now it should be flexible for the future requirements. Of course, the flexibility is very important. It should be user friendly. Clear? So next, it must be reliable. Means that, see, if I'm using a particular process for a longer period, if I'm using that particular thing, particular application for a longer period, it should not get relaxed. Means that it should not show me an error. See, I'm working for so long, I feel tired, just adjust with my errored output. Will you be acceptable with that concept? No, right? How long it is used, it should not show any errored signal. Means the downtime should not be more than 0.1%. Okay, even though it's working for a longer time, it is got used for a longer time, the error signal should not show a error signal. The output should be accurate. Clear? And your final point is said to be, it should be effective communication system. Means that communication system, in the sense human communication system. See, the entire operation will be according to the computer language. Clear? The output should be in the human communication system. We have to understand what exactly happening. The output, by seeing the output, we have to understand. It should be communicating with us in a human communication language, even though processing is happened in a computer language. Clear? Entire thing is happening in a computer. When it is coming out, it should be it should be understandable for your humans. Clear? So these are the important objectives of data acquisition system. If we consider the application, they are used in research purposes, they are used in industries. So this is seems to a quite hot topic in your measurement and instrument station. So hope you understand what exactly the data acquisition system is, and in this session you have seen the block diagram and the various controls system. So these are the important points regarding your data acquisition system, the objectives of your data acquisition system. In the entire session you have understood, hope you have understood what exactly your data acquisition system is, what it is mainly used for, its block diagram, various components, various processing units you have understood, and its objectives. I hope this will be very useful for you guys. If you have any doubts or questions, please write your questions in the comments, and thank you.